Hey everyone, Sir Pixelton here. Welcome back to our Unreal Engine 5 Fundamentals series. In the last video, we explored functions, which helped us organize our code and make it more reusable. Today, we're taking things up a notch with blueprint interfaces. This powerful feature will completely change how your game objects communicate with each other, making your projects more organized and way easier to expand. Let's dive in. So, what exactly is a blueprint interface? Think of it as a special contract between different blueprints in your game. When a blueprint implements an interface, it's promising to include certain functions that other blueprints can call. Imagine you are playing Fortnite. You press the interactive key, which typically is the E key, and you might open a door, pick up an item, loot a chest, getting a car, or even use a zipline. These objects are completely different, but they all need to respond to the same interact command. Without interfaces, your player character would need separate code for each interaction type, creating a mess of casting nodes and complex logic that is going to hinder the performance of your game. With blueprint interfaces, your character just says, hey, I want to interact with whatever I'm looking at, and any object that implements the interactable interface knows exactly how to respond. The door opens, the items get picked up, or the NPC starts talking. Before we start coding, let's talk about when you should use interfaces. Interfaces are perfect when 1. Multiple different objects need to share a common behavior. 2. You want to keep your code clean and avoid messy casting webs. 3. You plan to expand your game with new interactable objects later. With all these 3 keynotes in mind, it's safe to say that in almost all gameplay development cases, we're going to utilize blueprint interfaces very regularly. The classic example is an interaction system, which we'll build today, but interfaces are useful anywhere you need a different blueprints to share functionality. For example, you might create a damageable interface for anything that can take damage, a pickupable interface for items the player can collect, or a swimming interface for any character that can enter water. Each object can implement these interfaces in their own way, but the calling code stays simple and clean. Let's create a simple interaction system using interfaces. We will make a door that opens when the player presses E while looking at it. First, we need to create our interface. Right-click in the content browser, select Blueprint and Blueprint Interface. I'm going to name it BPI_interact. And of course, I like to prefix interfaces with BPI, which stands for Blueprint Interface, to keep things organized. And after the renaming, let's open it up. You'll notice the interface looks different from regular blueprints. That's because interfaces only declare functions, which is why it says read only, and they don't implement them. The actual code will live in the blueprints that uses this interface. In this demo, we're going to put it in the door blueprint actor. Now, let's remove the new function that is coming in by default, and click on the plus button on the top right corner, and we're going to create a new function and name it onInteract. And let's add an input parameter called interactive actor. And we're going to change this to an actor type. This will let any interactable objects know who is actually interacting with it. But in our cases, we're not going to use this for today's lesson. Alright, that's it. Our interface is ready. And let's save and compile, and we can close this window. Now, let's create a door that uses our interface. Right-click on the content browser once again, and we can go to the Blueprint class button. And we're going to choose the actor parent class, and we're going to name it BP, which stands for Blueprint_door. And let's double-click and open it. And under the default scene root, we're going to add a static mesh component. And we're going to rename this to door. And on the details panel on the right-hand side, under the static mesh section, we're going to click on the drop-down, type in door, and we're going to pick the static mesh_door object. And keynote, we're not going to delete the default scene root because we want the pivot on the door so we can rotate it properly in later. Now, for the important part, implementing our interface. Click on the class settings at the top of the blueprint editor. In the details panel on the right, at the very bottom, you will see implemented interfaces. We're going to click on add and type in BPI, and we should see the BPI_interact interface we have just created. We're going to select that, compile, and you should see on the My Blueprint panel on the left hand side, under the interface section, we see the onInteract function we have just created. To start implementing our interface, all we need to do is double click on onInteract to open the event graph. For this demo, I will keep it simple. When the player interacts with the door, we will just simply rotate it 90 degrees. So we will need a timeline node to animate this door smoothly. So let's drag out from the event onInteract execution pin and type in timeline. And I'm going to name this door timeline. And double click on door timeline. We're going to press the track button and add a float track. Right click on the chart and click add key to curve float underscore 0. We're going to do it one more time so we have 2 key nodes. Select the first key node we have just created, put in 0 on the time and 0 on the value. Select the second key node we created, put in 1 on the time and put in 1 on the value. And just like that, we can close this tab. And now you can see on the door timeline, we have a new output pin, which is new track 0. Of course, we can rename it to whatever we see fit. We're going to drag out from the update pin and search up set relative rotation. And we're going to pick the one that says door. And this will automatically set up the door as our target. Right click on the new rotation pin and we're going to split this. If you go back to the viewport, click on the door and press the E hotkey, which will be in the rotate object selection. And you can see we will probably want to manipulate the Z axis. So go back to the event graph and you can see the new rotation Z. That's the pin we want to manipulate. And to do so, we're going to drag out from the new track 0 pin and type in lerp. And this is going to help us to achieve the smooth opening door effect. We're going to move the connection from the A pin to the alpha. And I'm going to type in -90 to the B. And just like that, we're going to connect the return value to the new rotation Z. And of course, we can't forget the flip-flop node, which will help us to achieve the toggle effect when we open and close the door. So let's drag out from the event node once again and type in flip-flop. And the first execution is going to be play, and the second execution is going to be reverse. So later on, when we press E to a closed door, it's going to open it smoothly. And if we press E again on the open door, it's going to close it smoothly. This is where the real power of interface comes in. Each interactable object can have completely different code inside its onInteract event, but they can all be triggered the same way. Now let's set up our player character to interact with these objects. Let's compile and save, and we can close the BP_door. And if you remember correctly, throughout this fundamental series course, we have been using the level blueprint to act as a player character blueprint. So we're going to open up the level blueprint once again, and you can see we still have the spawn projectile functionality on the top. And we're going to simply right click on the event graph, type in keyboard. And the reason for that is I'm going to find the E key, and I'm going to call the onInteract function whenever we press the E key next to a door. So let's continue on from the pressed execution pin, and let's add a line trace when the player presses E. So we're just going to simply type in line trace by channel, and let's give it some space. We're going to add some different nodes here. And on the out hit pin, we're going to drag it out and select the break hit result. And this is going to be useful later on. Let's go back to the left side of the line trace. And similar to how we're going to spawn our projectile, we're going to spawn a trace line from the camera position to approximately 200 units forward. So let's go up and double click on the spawn projectile. And let's select these 3 nodes and copy them. We're going to go back to the event graph and paste them in open area here. And this is going to be very helpful because it's pretty much the same principle here. The one extra node we will need is make literal float. And for the value, as we discussed earlier, we're going to type in 200. Now for the start location for our line trace, we can just simply plug in the get actor location, but we will need some calculation for the end location. Now drag out the return value from the get control rotation and type in multiply. And we're going to multiply with make literal float node. And their result is going to be added to the get actor location. So we're going to type in add. and drag in the two nodes separately. And their result is going to be the end location for our line trace. Let's go to the draw debug type and select the for duration, and the draw time is going to be 5 seconds. This is going to help us later on in debugging. Now for the magic part. When we hit something, instead of checking what type it is with casting, we will check if it implements our interface. So let's drag out from the hit actor and type in does object implement interface. And we can select the class we have implemented, which is BPI underscore interact. And if this hit actor does indeed have the interface implemented, we will branch out from the branch node, and through the true execution pin, we're going to finally call our onInteract message. And the target for this onInteract is going to be the hit actor. And we're going to connect the execution pin from the line trace to the branch node. That's it. No complex casting chain. No need to know what type of object we're hitting. If it implements our interface, we can interact with it. And of course, does object implement interface node is kind of redundant, because at the end of the day, if the actor that is being hit by the trace line doesn't have an interface, it would just do nothing. So it's up to you to have this part or not. Now let's test out our system. I'm going to compile and save, and I'm just going to close out the blueprint. And of course, to start testing, we have to place our door in the level. So let me fly outside our office, open up the content drawer, and drag in the BP underscore door object. And I'm going to place it somewhere in a reasonable spot at our door frame. And this seems a little small for our door frame, so I'm just going to press R, which is the hotkey for scaling an object, and press on the white cube here so we can scale it uniformly. And I'm going to scale it like that. And that seems pretty reasonable. That's basically double the original size. And let's see, press play. And there's one issue. We can fly through the door as if there's nothing stopping us. And there's a reason for that. Let's press escape. And in the top left, you see there's a drop down saying lit, which is the current view mode. If we go to the player collision mode, you'll see there's no door in the viewport. That's because the door static mesh doesn't have a player collision by default. So let's go back to the lit view. And I'm going to open up the content drawer once again. And in the search content, I'm just going to type in door. And you can see here, there's the door static mesh. Let's double click on that. And go to the collision dropdown located on the top of the window. We can see there's the add box simplify collision button. And after that, the Unreal Engine is going to generate a very simple box collision around our door frame. And let's save this, close it up. And now if we press play, we can no longer fly through the door because there's going to be a player collision. Now let's see. Let's get close to our door, approximately within 200 units. And by looking at the door, we can press E, and this is going to open our door very slowly. And let's go to the other side and press E again. Uh-oh. This is not closing the door as it's supposed to. Let's see what's the issue. Let me go back to the BP underscore door. And if we see double click on the door timeline, the track we have created has 5 seconds in length. But the two keynote we have created only starts from 0 and ends at 1 second. So there's 4 more seconds after the animation that the door is not going to take any commands from. So this is a very simple fix. We're just going to change the 5 to 1 second. And let's compile and save. And if we press play to test out our door finally, we can press E to open the door, walk past the door, and we can press E again, and the door should close it up. And the beauty is that we can now make anything interactable just by implementing our interface. Meaning add a light switch, a pickup item, or anything else that you desire. No need to modify our player character code whatsoever. And there you have it. Blueprint interfaces are a powerful tool that will make your projects more organized and easier to expand. Next time you are building a feature that multiple different objects might need to share, think about interface. If you enjoyed this tutorial, hit that like button and subscribe for more Unreal Engine 5 content. In our next video, we will look at Event Dispatcher, another powerful communication tool in Unreal Engine. Until then, happy developing, and I will see you in the next one. Bye bye.